Hello guys. So have you tried to register for the, if you haven't done so before, have you tried to register to the My Open Math section? You were prohibited because of late registration. The system was not letting you in, but I contacted Professor Suzuki, and last he said is that he extended the registration. Yes? Anyone is not yet on My Open Math Lab? So have you tried to register after, if you are not there? And if it's still not on, I will wait a little bit and send him the message. We have still a little bit of time. Yes, okay. He might have not extended it. He said he will do it, but I haven't heard after the message yesterday. I haven't heard anything else extra. Okay. So the reason you were not able to register is because the system had so after a certain date was not letting you in, but it should have been extended.
Yes, الحمد لله. Thank you for no, very fair.
All right, guys. So let's get to work. All right. So we have started antiderivatives, correct? And you have seen that, for example, if I am interested in the antiderivative of x cubed, the antiderivative, in other words, it might be something like x to the power of 4 times 1/4 plus a constant. Yes? Mute yourself, guys, if you are joining the meeting and you're not speaking. So what I say is understandable? All right, can you hear me, guys? Yes? So here is where I was. X cubed, what's the antiderivative of x cubed? The antiderivative, it's what? So you see the power rule, you have x cubed, and I can write x to the 4, and I see that x to the 4 is not quite right, so I multiply it by 1/4 and I add a constant. Yes? Now I'm going to ask you a very important question, and think about it. Is it the only possibility for antiderivatives of x cubed? Could there be something that I haven't seen before that's an entirely different function, other than the family 1/4 x cubed plus c? That's very important if you can figure it out. Do you understand my question? Here again, on the whiteboard, what is, if I have that the derivative of my function equals to x cubed, then I might guess that my function is equal to x to the power of 4 times 1/4 plus c. Would you make the same guess? Write in the comments if I were to write the antiderivative for, would you make the same guess as I have? here for what was the original problem. That's good, right? So you understand how I do it. I see x cubed, and I know that when I use power rule, when I differentiate, the power drops down, and you subtract 1 from it, right? So then I think that's a good guess. Good. Now, my question is, could there be anything other than this guess? Could there be another function that's very exotic that also has the same derivative, that also has the derivative x cubed? That's not like that's not like 1/4 x to the 4 plus 1, or 1/4 x to the 4 plus pi. You understand what those means, right? So a family where you just have 1/4 x to the 4 plus a number. Could there be something more exotic? That's a very, very important question. You have seen the movie The Usual Suspect with Kevin Spacey. Kaiser Soze, right? Is Kaiser Soze among us, among this family, or maybe he's not here? That's the question. No idea. Well, you see, how can you right away figure the answer to this question? Do you remember what is a derivative? The derivative is the blind man touch. If you remember The Scent of the Woman with Al Pacino, right? So what you can do, if you understand what the derivative is, you can understand the shape of something. Am I right? You see what I'm saying? Why can you understand the shape of something? Because you can imagine that, let's say, if this is a beautiful contour, right? So think about it, right? What do you do when you apply the tangent? You are touching the curve. So that means here is a line segment. Here is another line segment. Here is another line segment, another line segment, another line segment. Right? Now, if two functions have the same derivative, it means that the line segments are what with respect to one another? Do you follow me, guys? Here, two curves have the same derivative. It means, because derivative measures the slope of those line segments. So it means that what happens? Are you with me, guys, or too early in the morning for such things? What happens? If I touch, if the derivative is the same, that means the line segments at any point where I touch are what? What word am I missing here? Exactly, Christian. One person kind of understands me. They are parallel. What about the rest of you? Do you understand that if I have derivative is measuring slope? You understand what I mean? It's very important to be able to think simply. What is the derivative talking about? The slope along the curves, right? So of course the line segments, there are many. If you zoom in, there are more line segments. It's like infinitesimal line segments building up the curve, which you can approximate by having line segments that are extremely short, right? And they are oriented along the curve. And when you take the derivative, you're simply recording their slopes. Do you understand? So when you calculate the derivative, you simply record what is this slope. This is a negative slope, negative some number, right? And this is another negative, and this is even more negative, less negative. Finally, this one is positive. You're recording the slopes of those tiles, of those line segments, and that orients them in position. Yes. If the slopes are all the same, it becomes a straight line. Because all the line segments are aligned in the same direction. If the slopes are variables, they're changing, then it's a sort of curve. And if you have two functions with the same slopes everywhere, right? So that means they have the same derivatives. It means the curves are what? if two curves have the same derivative everywhere. In other words, if I have one function, I have gx is such that the derivative is the same as x cubed, right? So how is gx and x to the 4 1/4 related? Do you understand my question, right? 1/4 x to the 4, when I take the derivative, it will be x cubed. Now take any other function whose derivative is equal to x cubed. How is that gx related to 1/4 x to the power of 4? Is it related? I need you guys your best thinking today. Is it related? Why is there a silence? Is it related? How is it related? And why do you reach your conclusion? Okay, so Leiki says something. Now, I don't want to voice it to all of you, to you, Leiki, and to everybody else. So you're missing one small part. What's the, so you are saying that, but tell me why. The rest of you, tell me, please. Do you follow, guys? It's a very simple idea. What is a curve? From the perspective of the derivative, from the perspective of calculus, it's just a chain. Have you ever seen chains? Chains with small linear segments, and you just fold those linear segments, and the lines are the linear segments are just line segments. They have slopes. Good. So if I observe that two chains have the same orientation for slopes. In other words, I know that I have a function and its curve g prime x has slope x cubed at any point x, and then we know that if I take the derivative of 1/4 x to the 4, that will be also true. Okay, so my question is, how are the curves 1/4 x to the 4 and g of x, the unknown curve, related? Do you understand the question, guys? Let's look at, wonderful, Heidi, you just got it exactly. The curves are parallel. They must be parallel. Do you understand why they must be parallel, guys? Think about the situation. So if I calculate the derivative along this red segment and the derivative is the same, it means that the line segments are parallel. Otherwise, I would have not measured the same slope, right? Derivative is just measuring infinitesimal slope of this parallel line. Over here, also parallel. Over here, they must be parallel. Over here, they must be parallel. Over here, they must be parallel. Do you see what happens here? I am tracing a curve that must be parallel to the other one. Do you understand that? Very important, guys. Do you confirm if you do? Right? If at any point there was no parallelity between the line segments approximating the curve, between the tangent lines, then the derivatives would not have been the same. Do you understand? So that means what? Okay, Heidi understands it. What about the rest of you? I don't see much participation here. What about the rest of you guys? Do you understand? Very important. You see how simple it is to reach this conclusion without any very complicated tools. If you realize what basically is the derivative, very obvious what happens. Good. So that means what? That means, in terms of back to functions, it means that, look at it, if g prime of x equal to x cubed, then how do I express that g of x is parallel? Then the curve g of x equal to y is parallel to the curve 1/4 x to the power of 4. Do you agree? Because equal to y. Because if I take the derivative of 1/4 x to the 4, I get x cubed, which is what I get if I take the derivative of g. You understand? That means they have the same slope. So small line segments over same x value, right? Have the same slope. You understand? That's how I see it geometrically. So that means what? That means that g of x is equal to what? How do you express in terms of function? What does it mean for two curves to be parallel if I have them on the xy coordinate plane? That means it is the same curve but shifted by a constant. Do you understand? That means that g of x is 1/4 x to the power of 4 plus a constant. Are you with me? Very important idea, extremely important. In other words, it's among my usual suspects. Clear? Guys, it has to be crystal clear, right? You understand why I added the C, how I'm thinking. So I know that if I add the C, I have captured the totality of all possibilities. There is no other function that will, no exotic functions can be possible. You understand? I know all my possible antiderivatives. I know every single possible question that might have led to the derivative equaling x cubed. Good? And that's going to be extremely useful when I go on through this course. Okay, usual suspect. I need to know all of them so that I'm not making a mistake. So here, you will soon see exotic looking functions. G of x equal to the integral from 0 to x to u du, something like that you will see, okay? And you will know that this function, when you take the derivative, you will see later. It kind of looks scary, but when you take the derivative is 2x. You understand? The derivative of this weird expression is 2x. Could you give me a simple formula for g of x? To the best of your ability right now, right? So I'm not, you see, can you think theoretically like this? Take the derivative of g and you will get to x. If what I'm saying is true, what must be g of x? Write in the comments. Think hypothetically, God, right? If I had big wings, I could fly instead of driving in the traffic, right? That's a hypothetical. So if I tell you that the derivative of this function is 2x, what must be the original function? What might be a simpler formula than this scary looking expression that you don't understand? Who? You got me exactly. What about the rest of you? Why does it take so long? Come on, right. Good, Jonathan. Good, good, right? I might not immediately know the C, but I know that this scary looking formula can be replaced by a much less scary formula, because I know only x squared plus a constant could possibly be an antiderivative of 2x. Do you understand? So that's going to be something that we will use shortly, I hope. So here you have, guys. Can you help me guess this formula? Derivative is 1 over 1 plus x squared. What is f of x, to the best of your knowledge? Okay, good. Good, good, good. It is inverse tangent plus a constant. Because you remember that the derivative of tangent inverse is 1 over 1 plus x squared. Right? Here, by the way, here is another question. Let me do it this way. Are you ready, guys? So what is the derivative of tangent inverse x plus cotangent inverse of x? And see if you can do it very simply. So what is that equal to? Write in the comments, please. Okay, very good. The answer is 0. What does it mean? What do I know from it about tangent? What does it mean about tangent x? Tangent inverse x plus cotangent inverse x is equal to what? If the derivative is 0, it means that tangent inverse plus cotangent inverse is equal to a what? I found that this expression having x, the derivative is equal to 0. That means tangent inverse plus cotangent inverse is what? Simple, guys. Derivative is equal to 0. Right away, you think what? Exactly. If the derivative is equal to 0, what picture? I tell you what picture I have in my head. What picture I have in my head is that the tiny line segments that are building up this curve are all aligned. And because the derivative here is their slope, they are all horizontal. You understand? I have lots of line segments. So I imagine the line segments could be attached who knows how. They are all aligned and they're all parallel. I see the constant. Do you see the constant the same way? Right, very simply, everywhere derivative is 0, it means that the tiles, I imagine the tiles building the curve, they're all aligned and they are all horizontal. So that means it is a constant. Do you understand? Please confirm if you do, or I mean, I don't see enough of you participating. Makes me worried that you don't understand it. Yes? Very simple reasoning here, right? So it's constant. Now, why is it a constant? Let's now understand what sort of constant is it. We can draw a triangle, right? What is tangent inverse of x? I can draw a triangle. And this angle I can label as tangent inverse x. Tell me how to label the sides. So the opposite side can be labeled as, Okay, finally, right? Opposite over adjacent, so x, and then the adjacent can be labeled as 1. Do you all understand that? Because what is tangent inverse x? Apply tangent, you get opposite over adjacent. This is the pi over 2 angle, right? Opposite over adjacent, the ratio has to be equal to x. So a simple way to obtain such a ratio is to put x on the opposite side and 1 on the adjacent side, right? The hypotenuse will then be 1 plus x squared. Agreed? Take this squared plus this squared and take the square root. Now, this angle, I can also write x over 1 if I place here cotangent inverse. Cotangent inverse means adjacent over opposite, right? So then what is the value exactly of tangent inverse plus cotangent inverse, please? Is exactly what value? Finally, one person sees that. What about the rest of you? Come on, guys. You see, that's why it takes so long. I mean, I see no response. I imagine you're in frozen water. Blood is cold. Those angles add up all together to pi. All the three angles add up to pi. So the two angles, tangent inverse and cotangent inverse, must add up to pi over 2. As simple as that. Yes? Should not take any time to figure that. All right, back to this thing. Similar thing is yeah, I forgot about it, right? So again, I already answered this question, but in general, let's see if you can think abstractly. If you have the derivative f prime x is equal to g prime x for two functions f of x and g of x, what's the best you can say about the relationship between the two? F prime x equal to g prime of x. They have the same derivative. What can you say about the relationship between the two? Wonderful, wonderful. Two people are seeing it. What about the rest of you? Why only two answers and why so long? Come on, should be immediately many comments. I do not know. I imagine your faces are like this. Are you alive? Do you have oxygen? Have you slept enough? What's the answer? All right, I guess whatever. So the way I answered it, I suppose then, if you asked Freud, he might have said, diese zwei haben eine verborgene Beziehung, in der Öffentlichkeit halten sie sich voneinander in Abstand. These two have a hidden relationship. They keep their distance from each other in public. You see? That's how. That's why it's not boring to me, right? So I see all this nonsense. So why does it mean exactly? We can understand this statement as follows. If I take the difference between g and f, it's k of x, some function, g of x minus f of x, then I take the derivative of that function, it would be g prime minus f prime, which would be 0, right? So there is this, so k of x is equal to a constant. Do you agree? K of x must be a constant because the derivative is 0. Are you with me? And if it's a constant, that means that g of x is equal to f of x plus c. They are very similar. Good? Here is, I'm not sure how you would enjoy this, this thing. Imagine that I find some function, some alien finds you a function, and the function is written this way. Very weird symbol, x over here. And it's told that the derivative of this function is 2x. What is a normal, nice, simple formula for this function to the best of your ability? You see this ugly thing? What's the derivative? And you are told this alien, you research it, you say, oh, actually the derivative equals of this function, whatever this operation, it happens to be 2x. What is this operation? So you're discovering alien notation, whatnot, right? This operation is what? It's not a lobotomy. It's something else. Exactly. It is the alien function like you mean x squared plus 2. And Heidi, yes, it is x squared plus c, sorry, right? X squared plus some constant. That's the best we know at the moment. Okay. So here is a preview of U substitution. Okay, what is U substitution? It's a strange name for something that can be called reverse chain rule. Okay, so suppose that I find that the derivative of a function is cosine x squared times 2x. Let's see how good you're at guessing. Can you tell me what must have been the original function? Wonderful. Christian, you see it right away. Sumaya, wonderful, beautiful. Beautiful, Leiki. And what about the rest of you? You see, you realize that, look at it. It looks like somebody carried chain rule. So derivative of outer function is cosine. So then you guess that the outer function must have been sine for this to be true. Yes? The outer function must have been sine. And so you can think of it this way. There is bx, the big fish, and sx, the small fish. And if the big fish ate the small fish and you take the derivative, you see the fillet of the big fish, the derivative of b with the small fish in its belly times the derivative of the small fish. So we see that the derivative of the big fish is cosine. So we guess that the original function, the big fish, was sine. And the small fish, here it is, and here is its derivative. So my guess is sine x squared plus c. Okay? Now, can you figure out what to do now? Very simple question, guys. Very similar. Now we have cosine x squared times x. What is the antiderivative? What was the original function like? Antiderivative of cosine x squared times x, please. That's very good, Lisha. So you see, you look at it and you think, well, we see inside of cosine is x squared, and it should be multiplied by the derivative of x squared, which is by 2x, right? So what I do is I put a 2 and I multiply by 1/2. This is what I do. I want there to be a 2 because now cosine x squared times 2x is a perfect chain rule. And there is just a multiplication by 1/2, which I can always ignore. When I take antiderivatives, the derivative jumps through a constant, right? So that would be 1/2 sine x squared plus a constant. Do you see where the 1/2 came about, guys? And here, okay, so let's, before we continue, here is going to be the symbol that asks us to take antiderivatives, right? So this is the definition, and we will see hopefully shortly why that is done, right? So when you see, this is like an elongated s, f of x dx, that means find a function whose derivative is this little f of x. Find some capital F such that when you take its derivative, it will give you little f. Okay, so for instance, when I say integral 3x squared dx, I am asking for a function whose derivative is 3x squared. So I will write x cubed plus c. Those are the totality of functions, yes? Or if I have integral of 5x squared plus e to the x, I'm asking what function might have produced 5x squared plus e to the x as its derivative. And I write 5 over 3x cubed plus e to the x plus c. Good. And of course, you can notice that the integral of the sum is the sum of the integrals. Because if I guess antiderivative of one function and that of the other, the sum of them will be the antiderivative of the f of x plus g of x. Because derivatives are additive. Good? And I can always factor a constant because when I need to guess the antiderivative, I only have to guess the one for little f, and then I can multiply it by a scalar. Okay, guys, here is your opportunity to shine. Do A. Can you guess what was the function that produced x squared times root of x cubed plus 1? Can you guess what that might have been? Think about it, guys. What do you see here? I will help you in a moment. One more minute, and then we'll see how to do it. All right, let's work on it together if it takes time. Okay, Muhammad. Okay, what is it? It's a root. It's a square root. You mean something else? Okay, here. Let's look at it carefully, guys. So your eyes are scanning this object, and you're asking yourself, what is this function that I am trying to find antiderivative for? So first I see that x cubed plus 1, its derivative is kind of like x squared, which I see outside, yes? In particular, the only thing that's missing is I would have liked to have a 3 in front of it, because the derivative of x cubed plus 1 is 3x squared. So that would be the inner function, yes? Inner function is x cubed plus 1, and if you multiply by the derivative of the inner function, you think chain rule is happening here. So I put a 3 and I multiply by 1/3. I can ignore the 1/3 and just carry out the antiderivative of this expression. Are you with me? Are you with me, guys? Very important step. So then what is this? In other words, I need to only find the antiderivative of the outer function, because the chain rule works like this: derivative of outer function, inside you see the inner function, times the derivative of the inner function. All I have to figure out is the antiderivative of the root now. The antiderivative of the root, it's the antiderivative of to the power of 1/2, which is 3/2. Yes, 3/2 multiplied by 2/3, because this number has to be multiplied by the reciprocal, so it disappears when I take the derivative. Are you with me? I add 1 and I write 1 over this number that I obtained. And then there is another 1/3 that I had to place in front of it. So the answer is 2 divided by 9, x cubed plus 1 to the power of 3/2 plus a constant. Are you with me? Do you understand what I did? All right. So my eyes completely ignored. Once I put the 3 here, my eyes completely ignored everything other than the square root, other than the 1/2 power. How do I take the antiderivative of the 1/2 power? I add 1, getting the power of 3/2, and multiplying by the reciprocal by 2/3 to cancel the 3/2 when I take the derivative. Confirm if you understood the explanation, please. That in essence, that you see, if you watch it carefully, then this is pretty much all I have to worry about. Did you understand, guys? And the rest of you? Okay. And the rest of you, where the 2/3 come from, because look at it, you see the 3/2? When I take the antiderivative of 1/2, it's 1/2 plus 1, which is 3/2. Now, if I were to take the derivative, the 3/2 will drop in front, and I need it to be cancelled because I don't see 3/2 in front of this expression. So when I multiply by 2/3, the 3/2 times 2/3 annihilate each other. Yes? Okay, good. Now let's see how well you understood. Look at B, guys. Look at B and tell me what's the answer for B. If you understand it, you should see it very fast. Okay, Ibad and Kirill, you see it. I see two people that understand it. What about the rest of you? All right, so let's do it together. It's very simple. You say you understand it. I scan with my eyes. I see cosine cubed, sine. I know that the derivative of cosine is essentially sine. It's minus sine, but it's very close. Good? So this is what I do. I look at this expression that I see that it looks like a cube has eaten cosine. Yes? And it looks like chain rule worked because look at it. If the derivative happened to be minus sine, I need a minus here, right? Derivative, if cosine is the inner, I should see if it's chain rule, I should see multiplication by the derivative of the inner function. So I put a minus one here. And because I never had a minus one, I multiply by minus one on the outside. Yes? And now what happened here is that it's now all I have to worry about is what's the antiderivative of the cube function, which would be 1/4 to the power of 4. You understand why? Because if I find the antiderivative of the outer function, I have, when I take the derivative, it will be the derivative of the outer function multiplied by the derivative of the inner function, right? So you would see the inner function inside, and yeah, so the answer is minus 1/4 cosine to the 4 plus c. As simple as that. Do you see that? So if you see that, here is your question C. Please tell me what is the result for C. That should be very fast. You understand? You're supposed to be so good at recognizing chain rule that you can immediately reverse it, right? Because you see that this derivative came about from chain rule. If that happens, you only need to find the antiderivative of the outer function. Do you see that, by the way? All right, so what's the antiderivative of, before maybe, I don't know, so many of you are silent, let me just do this one thing. Here, that's why formal reasoning is so nice. What is chain rule? I see that chain rule has happened if I have derivative of f, then I have the inner function times the inner function. Yes? When I see this, I right away look at it. Someone was doing chain rule. Do you have that feeling right away? You should. So then, how could I have reversed it? If I can guess the antiderivative of the outer function, that would be some function f, right? So then I place g of x in it. Notice what would have happened. If I took the derivative of that, I would get the derivative of the outer function multiplied by the derivative of the inner function, right? You understand? I understand this thing is just a plan of the strategy. I understand what my strategy will be. I see that all I have to do is figure out the antiderivative of the outermost function. Once I realize it's chain rule, all I have to do is ignore everything here and just find the antiderivative of the outer function. And if you understand now, then please tell me quickly what's C. That's very good, Christian. And what about the rest of you? Okay, maybe 3 people, 4. Good, 5, 6. 7. There are 29 students here today. What about, so 7 is not good enough. I want more. Come on. Nine. Still only a third of the class. What about the rest of you? Great. Okay, a few more added. Okay, you understand, guys, how I see this problem? Once I realize it's chain rule, I do not see anything other than this cosine. Good, Heidi. Once I see it's chain rule, I don't see anything. It's just cosine here, right? So what's the antiderivative of cosine? I write sine. You understand how I think? Cosine and the derivative is sine. And then I put in the inner function. That's it, I'm done. Plus a C. You can add the C, right? Understood? It's that simple. All right, so not all of them look so nice. Maybe some of them make you confused. Let's see, what about D? Can you tell me what is the answer to D? It's Z squared over Z cubed plus 1. Can you recognize what might have been happening here? That's nice, Kirill. Very good. Ibad, very good. All right, so what's the answer? Very simply, you just have to recognize that it is 1 over Z cubed plus 1. And that looks like 1 over X has eaten a Z cubed plus 1. And the derivative of Z cubed plus 1, that's how I recognize. I look at it, I see Z cubed plus 1, its derivative will be 3Z squared. Yes? but I only have a z squared. So I put a 3 and I multiply by a third. So now I put the 1/3 outside and I just see this is a perfect chain rule. You see this? So what's the antiderivative of the outer function? It's ln of absolute value z cubed plus 1, and I multiply by a third. And here is another set of exercises. Place something in the box and don't put 0 or, don't put 0 or don't put 1 over the function. That's too easy, right? Place something in the box and then figure the integral. What would make it easy if I place some value in the box here? Okay, for a, what would you like to place in the box, and then what's the integral? For a, it would be, what would you like to place inside of the box? Yes, Ibad, very good. So for a, guys, what would you put in the box to make the integral very simple? So, and then tell me what's the antiderivative. Yes, Christian, absolutely right. I'm just trying to show you how such problems are built up, you understand? So they call it U substitution. You will see maybe later why, but again, I call it reverse chain rule. That's more so its Indian name. So A, what do I place? Again, guys, I only saw a few answers. Why not more of you? I've seen 2 people answer. There are 30 people here. What do you place in this box to make it easy? Other than 0 or 1 over sine x cubed, it's kind of, those are not interesting. What else can you place to make it easy? Yes, Catherine, and yes, Muhammad. And then once you place it in, just you might write in one line what happens if you place this thing in the box. What would be the integral? Very good, Ibad. So the answer for A, I would place 3x squared, because that's the derivative of the inner function. You see x cubed here. If I place the derivative of it, that will make it very simple to integrate, because then I just have to guess the antiderivative of sine. You understand? I ignore everything. I just guess the antiderivative of sine, which is minus cosine. I put in the inner function plus c. That's how simple it is. What about B? What do you put in B here? And then what's the integral? Lisha, very good. And then what's the integral? Yes, Muhammad, but what's the integral as well? You can write it in one line, what you place in, and then what's the antiderivative. Very good, Muhammad. So for B, I place 1 over 1 plus x squared, and then the integral becomes e to the tangent inverse plus x, plus c, sorry. Okay. Now let's talk about area under the curve. So we want to introduce, first of all, something known as sigma notation. So the sigma notation is just a convenient way to record that you are adding a bunch of terms. So if you have a sub k, the index indicates which term you're adding. The summation from k1 to n means just recursively just put, first of all, 1 instead of k, then plus put 2 instead of k, plus put 3 instead of k, and you continue until you get to n. So that makes it unambiguous, okay? So let's write in expanded form what is the summation k equal 1 to 5 of 1 over k. So for a, that simply is 1 over 1, 1 over plus 1 over 2, plus 1 over 3, plus 1 over 4, plus 1 over 5. Good? What it is for b, where the summation starts at 3 and goes to 6, it means k is initially 3, then k will be updated to 4, then to 5, then to 6. So for b, it will be 2 times 3, plus 2 times 4, plus 2 times 5, plus 2 times 6. Right? It's the sum of even numbers. You see, 6 plus 8 plus 10 plus 12. The summation for k cubed, it's similar idea, right? For k cubed, it is, what happened here? I think I glitched and I haven't, no, it's from 6 to 6, it's okay. It's from 6 to 6, so there is only one term that I will put. Make sense? There is only one term that I put. All right, so now we have d. J is equal to minus 2 to 1 of j squared. What is that? So for d, it will be minus 2 squared plus minus 1 squared plus 0 squared plus 1 squared. You understand how it works, guys? Now, what do you think it will be for e? Where I have I equal to 2 all the way to I equal to 6 of 5. What do I write? Okay, good, Lakey, exactly. So it will be all 5. Again, it means I is equal to 2, you write 5, plus I equal to 3, it's 5. So you write this. You write, that's when I is equal to 2, it's 5. I is equal to 3, it's 5. You see, you write all those 5s. How many copies of 5 do you write? Well, let's count it. 6 minus 2 is how many copies of 5 will be after I write I equal to 2. So it's 6 minus 2 plus 1. 6. You understand why it's 6 minus 2 plus 1? So that would be 4 plus 1, it would be 5 copies of 5. 6 minus 2 will tell you how many more 5s we'll have after I equal to 2. So that's for 3, 4, 5, and 6. Right? 3, 4, 5, and 6. But then I add 1 to include the I equal to 2. That's why it's 6. You always take the top number minus the bottom number plus 1. Because top minus bottom, it's how many more after the bottom number, how many more will follow. And then plus 1 is to include the one on the bottom. Understood? And you have, let's say, summation where s equals to minus 3 to 0 of e to the 2s minus 1 will be e to the power of minus 2 times 3 minus 1 plus e to the minus 2 times 2. Basically, you have the number updating, right? Understood? It's going up. Now we can. This is just a few values to convert to sigma notation. So let's say 2 plus 3 plus 4 plus 5 plus 6 plus 7. How would you write in sigma notation? You can write in your comment something like maybe sigma or even s, right? Sum. Or s, whatever you like saying, and then you write what value goes here. Let's say k equal to something, and then you write this, and then what is the upper value in the comments. Let's see if you can do that. You understand? It doesn't matter which, of course, letter you use, k, j, whatnot. It's just what you call a dummy variable, just an index indicating how the sum should be updated. Okay, k equal to 2 to 7, fine. It's very simple, right? So here is how you write it. So summation k2 to 7 of k, or you can use another letter, okay? And then you have, how do you encode the odd numbers? You can think of odd numbers as 2 times a number plus 1. 2 times a number plus 1 makes it odd. So I can write it as, let's say, k equal to 0 to 5 of 2 times k plus 1. The summation 1 plus 3 plus 5 plus 7 plus 9 plus 11 is summation from 0 to 5 of 2k plus 1. Right? Summation of 2 plus 4 plus 6 plus 8 is 2 times k, where k is 1 all the way to 4. Do you all see that? I don't have time to wait too long, so I'm trying to move along, right? Okay, so you should, those should be simple. If I write -2 and I add them a bunch of times, so 4 times, that's a summation of -2, just like that, okay? And 1/2 plus 1/3 plus 1/4, I can say k equal to 2 to 4, 1 over 4, 1 over k, sorry, right? And onwards. Okay, and again, I mentioned dummy variable, you can replace it, you can replace k by any other index, and that means exactly the same thing. You see, I can say I equal to 1 to 6 of 3i. I don't like to use I because I reminds me of root of -1. You see, so I prefer to use other letters. Now, you see, always think about the meaning. You see, I can write the summation k equal 1 to 6 of k squared, or I can write the summation k equal to 3 to 8 of k minus 2 squared. It means exactly the same thing, because 3 minus 2 is 1, 4 minus 2 is 2, 5 minus 2 is 3, and onwards. 8 minus 2 is 6. You understand? So those two expressions mean exactly the same thing. Even though they look different, but they mean exactly the same thing. So both sums represent 1 squared plus 2 squared plus 3 squared plus 4 squared plus 5 squared plus 6 squared. So here are a few obvious properties of summation. Imagine that I have summation from k equal to m to n of ak plus bk. Now I can group the summation. I can group and add first the a's and then add the b's. That's why it's the sum of a's plus the sum of b's. And here it's the observation written. So am plus bm, am plus 1, bm plus 1. So that's what the summation means when I expand it. And then I just regroup the a's together and the b's together, and I have this result. Understood? You understand what I'm saying, guys? Is that this sigma notation is just a sum, nothing special about it. So I can, when I put it in this form, it's just am plus bm, am plus 1 plus bm plus 1. And then I can just regroup and add the a's first and then the b's second. And then I have this summation. Similarly, I can factor out the constant. Constant times ak means I have cam plus cam plus 1 and onwards. And I can factor the c, and I have this summation. So here are some important sums. First summation is just of a constant number, where I go from m to n. So it's m plus 1, n, right? How many times do I add the summation? Think about it, right? So this is m plus 0, m plus 1, m plus 2, all the way to m plus n minus m. So I add, you see, I'm just trying to show you how you subtract it. You see 0, 1, 2, n minus m. Do you understand? I just readjusted. The blue is giving me a nice way to count how many additions I have here. So if I go from m to n, I can imagine adding 0 to m, then adding 1 to m. Then what's the last number I have to add to get n? I have to add n minus m. And so how many terms do I have? 1 through n minus m, and there is the 0 term, so plus 1. From 0 to n minus m, there are n minus m plus 1 terms. You see, 1, 2, n minus m, that's n. So starting from second term to the last, I get n minus m terms. And then I have the 0 term, so I add plus 1. So that summation is simply the top number minus bottom number plus 1 times a. Do you understand? Yes, one person I see, a person shakes a head. The others, I have no idea what you do. Now here is another summation that's also important. Yeah, I hope it's simple, okay? So here is the summation of k equal 1 to n of k, so it's 1 plus 2 plus 3 all the way until you get to n. And there is this legend that a very cruel German elementary school teacher was making his students, he was kind of annoyed with them, and he would make them add up numbers 1 plus 2 plus 3 all the way to 100. Okay, so they would all work so long and of course make mistakes, except for one person who would immediately write it on his, they didn't use paper, it was expensive, so they had a small, like a small blackboard, right? And you would write on a small blackboard, he would just write it and says, here states, immediately, and he was always correct. And this small little guy was Carl Friedrich Gauss, the greatest mathematician that lived, right? One of them for sure. So how mighty Gauss have figured it so quickly? Well, obviously it was not going directly and adding those numbers. That's too slow and too silly. Here is how you might notice what the summation is. So we can write the sum in increasing order, 1 plus 2 plus 3 all the way to n, or I can write the summation in decreasing order. You understand? Starting from the biggest number and then go adding the next biggest and then adding the next biggest until I get to 1. And then if I add those two forms to themselves, I will get 2 times the sum, right? 2 times the sum. S plus S is 2S. Now, look what happens here. If I look at the columns, the first column is n plus 1. The second column will be the same because you can imagine the transference. So this n loses 1 and this 2 is gaining 1. So it's as if the entry in the lower row is losing a number and it's giving that number to the entry, the corresponding entry in the top row. Do you see that? So the additions here will be just a bunch of n plus 1s. N plus 1, n plus 1, n plus 1, n plus 1. How many additions do I have? I can use the top row to count them. There will be n such additions. So the answer is that 2 times s is n multiplied by n plus 1. And so s is n times n plus 1 over 2. Do you understand the idea? Understood? Look at it. This is the summation written in increasing order, the summation written in decreasing order. You add column wise, and the columns always equal. Look at it. 1 plus n is n plus 1. 2 plus n minus 1 is n plus 1. And when I do the addition this way, I just see by symmetry that that s plus s is 2s, and 2s happens to be the addition of the same number to itself. N plus 1 is added to itself how many times? 1, 2, 3, 4, all the way to n times. I'm using the top row to count how many additions I have. So I have n additions of the number n plus 1. And so that's my 2s. That's if I add them together. 2s is that. Good? And so s is equal to n times n plus 1 over 2. Good? Here is a simple example. 10 diplomats are in a meeting. How many handshakes take place if every diplomat must shake hands with every other diplomat exactly once? You understand? 10 diplomats are in the meeting, and each of them has to shake the hand of every single other guy. How many handshakes take place? Okay, Bud says 40. Now 45. That's good. Okay. Kirill 45. All right. Do you understand how we do that? It's very simple. So how can we think of it? So first diplomat can go and shake 9 people's hands, right? So the first diplomat will experience 9 handshakes. So the first diplomat now shook hands with everyone. He can be eliminated, right? So it's 9 handshakes. Then the second diplomat will have 8 handshakes, and the very last diplomat, the diplomat number 9 will then add 1 more handshake. So it's 9 plus 8 all the way plus 1. So the answer is 1 plus 2 plus 3 plus 4 all the way to 9, which is 9 multiplied by 10 divided by 2, or 45 handshakes must take place. Do you understand? Here is another example. Soon there will be Hanukkah. I'm not sure if you celebrate it. And Hanukkah, it has 9 sockets for the candles. The holiday runs for 8 days. And what you do on the first day, you light 2 candles. On the second day, you light 3 candles, and all the way to the 8th day, you're always increasing each day by 1 candle more. And then on the 8th day, you light all the 9 candles. You understand? So the question is, how many candles must be in the candle box? What's the minimal number of candles in the candle box to be enough for the full 8 days? First day, 2 candles. Second day, 3 candles. Third day, 4 candles. You understand? So calculate, tell me how many candles we must have in the box. Okay, thank you, Kirill. Yeah, very good. So 3 people or so answered it. Good. So let's look at the calculation. So I might do this if I want, all right? I mean, that's up to me. I see that the answer is 2 plus 3 plus 4 all the way plus 9. And what's missing for my formula is the plus 1. So if this is the summation, then S plus 1 will be 9 times 10 divided by 2, or 45. S plus 1 will be 45, right? Not S. And so then what is S? It's 45 minus 1. Good? You see why? Because I see the summation is consecutive integers all the way to 9, but they don't begin with 1. So what do? I add 1, and then I have the formula, and then I subtract it from that formula. Good? So it's 44. Now, here is another challenge, guys. Can you find a closed form? In other words, find the formula for summing, like we started with 2 and ended up at 9. What will happen if I start at the number m and end at n? What's the summation of the case? Please calculate the formula for it. All right. What's the answer? It should be very fast. All right. Very good, Christian. Okay, here we go. Ready, guys? So that should be very fast. So what's the idea here? Let's look at the idea. It should be quick. Okay, so what am I going to see? So I can write the summation in this order. I did it one way. I mean, I can do it another way. Maybe you would prefer this way. Okay, so I can do it. I can write m plus m plus 1 all the way to n. Or I can write it as n plus n minus 1 all the way to m, right? And of course, both are summations that equal to s. So if I add them, I see that 2 times s equals to what? It's equal to, well, I'm going to add those terms. I'm going to add those terms. Yes? So what do I see? I see that I'm always adding m plus n. Are you with me? You see why it should take a few seconds, right? M plus m plus n. How many times am I adding them? So let's look at here. Let's look here. It is going from 0 to 1 all the way to what? To m plus n minus m. You agree? So I see that it's from 0 to n minus m. So that means that this would be 0 all the way to n minus m. So that means I'm adding the same number to itself, n minus m plus 1 times. Why plus 1? Because there is also the 0. This is the 1 to n minus m and then the 0 term. So it's n minus m plus 1 multiplied by m plus n. And then all I have to do is divide by 2. Is it clear? You see, I was explaining it takes 2 seconds. And I'm not sure if you're, you see, how much do you practice, guys? You have to study for this thing, you have to practice a lot. Okay. Now, second property, it's a bit more difficult. We need to figure out the summation of k squared, which is 1 squared plus 2 squared plus 3 squared plus n squared. There is a very nice way to do that using combinatorial analysis because when I add up k squared, I right away think, well, somebody is talking about this guy and they don't know how old he is. He might be 2 years old or n plus 1 years old, all the way to n plus 1 years old, and he has 2 brothers that are younger than him. So knowing that, realizing that that might have been the conversation allows me to very quickly figure out a formula for it. But we haven't studied combinatorics. Of course, by the way, did I mention I'm teaching probability next semester? And if you are what you call a good student, I'm also teaching calculus. You're welcome to sit on the calculus again if you haven't learned it. Right? But if you are a good student, I might also give you some briefing over the winter break. You can join that class. One person from calculus is there from previous semester and actually finishes this course, and she's doing well. So you can sit in and I will teach you probability. And that's and if you want certain things that are kind of applied and are very interesting, very difficult, but interesting, I have a particular strategy for the subject. Okay. So yes, that's the combinatorial analysis I explained to those that understand how I can figure it, but we're going to go a different route. All right, so first we remember how to expand x plus 1 plus y to the power of n. We have this Pascal triangle. Okay, Pascal triangle. And using this Pascal triangle, I just, the way I write it is, the way I write it is I write 1, 1, and 1, and then what I do is I add those two numbers to get the middle guy. You understand? So I have 1, 1, 1. You add those things, you get 2. You have 1, 2, 1. You put 1. And then the next layer is 1. 1 plus 2 is 3. 2 plus 1 is 3, and then 1. That's a very quick hack to figure out the coefficients when you expand powers. Do you know it? So the next row is 1, 4, 6, 4, 1. Why? Because you see, how do I get this 4? I have 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is 4. Good? So I have this structure. So that means that, for example, x plus 1 plus y cubed, it's x cubed plus 3x squared y plus 3x y squared plus y cubed. So those are the coefficients. 1, x cubed, now x squared y is the next, times 3, 3, and 1. Okay, we will need we will actually need the cube to expand it. So instead of going through the sum k squared, where I'm going to actually figure out what is the summation k plus 1 cubed minus k cubed. The summation. I'm actually going to a higher power, but here I have k plus 1 cubed minus k cubed. And we're going to do it in 2 ways. One way is to just calculate what happens if I reduce those sums, right? So first of all, what am I truly adding? I'm adding the cubes, which are in this case are moving 1 up, and in this case, so that they are hurrying by 1 unit up. So the summation can be distributed to first term and second term. Do you see that? Do you see the step that where I distribute the sum? I can add the k plus 1 cubes first and then the k cubes second, and I subtract. And what is this part? It's just the sum of 2 cubed all the way to n plus 1 cubed. And what is this? It's the summation of 1 cubed all the way to n cubed. So what happens if I subtract one from the other? The only thing that survives is n plus 1 cubed minus 1. That's the only thing that's not cancelled. Are you with me, guys? You see, I move it apart. I realize this is just the summation 2 cubed all the way to n plus 1 cubed. I subtract 1 cubed all the way to n cubed. So what is remaining? From here, 2 cubed all the way to n cubed will be cancelled, and what doesn't get cancelled is 1 cubed, and here the one thing that doesn't get cancelled is n plus 1 cubed. So we have n plus 1 cubed minus 1 is the result of the summation. It's equal to n plus 1 cubed minus 1. Do you see that? Here I actually just readjusted. Look at it. I do it another way. I make it equal to the difference of the sums, and then I readjust the sums to make them look the same. So how do I do that? I simply write k equal to 2 to n plus 1 of k cubed. That's the same exact thing. You see that? Because the summation really is just saying 2 cubed plus 3 cubed all the way to n plus 1 cubed. So I have this sum minus that sum. So I can look at the sum and I can write it as summation from k2 to n of k cubed plus n plus 1 cubed. I just write the last term separately. And here I remove the first term. So it's minus 1 cubed minus the summation. And why do I do that? Is because this minus that is 0. And I have again n plus 1 cubed minus 1 cubed. Do you understand me, guys? Right? So this is n plus 1 cubed minus 1 cubed. If I expand n plus 1 cubed, I get n cubed plus 3n squared plus 3n plus 1. And then the 1 cancels. I get n cubed plus 3n squared plus 3n. You with me? On the other hand, and the rest of you guys, do you follow? Are you able to understand anything? Okay, good. It's just symbol pushing if you just know how to use it. Good. Now just see, guys, so you should, how do you study, right? So you might imagine that you understood because something was familiar. I kind of guided you through the steps, but you truly understand when you can derive it on your own. Like you don't look at anything, you just think about it, derive it on your own. That means you understood it really. Actively understood it, not passively, right? So on the other hand, what I can do is I can expand k plus 1 cubed minus k cubed. I expand k plus 1 cubed, it's k cubed plus 3k squared plus 3k plus 1 minus k cubed. Look at what happens. The summation, if I cancel it out, it's 3k squared plus 3k plus 1. And so what do I have here? I have 3 summation of k squared plus 3 summation of k plus the summation of 1. And this is the summation of the k squared is what I don't know, is what I want to find. You see, so I will have an equation. I will have this equal to something that I found. I know that this is 3 times n times n plus 1 over 2. And this is just 1 added to itself n times, so that's just n. So what I have is that this formula is what? This formula is, if I simplify, it's n plus 3n. Where is it? So you see you multiply it out and add n to it, and this is what you get: 3n squared plus 5n over 2 plus 3 summation of k squared. And so what we have is n cubed plus 3n squared plus 3n obtained from the telescoping sum is equal to 3 times the sum I want to understand plus this number. So then when I just readjust, I see that it's n cubed plus 3n squared plus 3n divided by 3 minus 3n squared plus 5n divided by 6. When I carry out the algebra, I obtain this formula: n times 2n plus 1 times n plus 1 over 6. Okay, so how do you know if you understood it? You do it on your own. And there is this question, you should try to see if you can carry this idea and find the exact sum of the k cubes. Okay, now here is the area problem. That's a central problem of integral calculus. Given a curve y equal to f of x over the x-axis, how do we go about computing the area? In mathematical notation, this will be the integral from a to b of f of x dx. That's what we are interested in. So in a moment, we will see what's the reason for that. This is an S. What's the reason for this notation? Okay, we're trying to figure out how to calculate area under the curve. Now, why would such a problem be interesting to us? Okay, why is this? Why area under the curve is an important idea? So here is, let's say, some possible illustration from probability. So suppose you wish to measure the prevalence of a certain illness in the general population. You pick a random sample of 1,000 individuals and find that 50 of them have the illness. What can be said about the frequency of this illness in the population? You understand? So that's a simple example that is very commonly heard about this day. How do you know how common is something? So it happens to be, I cannot explain to you why exactly now. It happens to be calculated by the beta distribution, which will be the area under the curve of x to the 50, 1 minus x to the 950. The 50 are the 50 people that you tested. And that would be this curve. And then you know that this disease is about 0.03 to 0.07% of the population have this illness. So 3% up to 7% of the population have this illness based on this estimate. Okay, and this is with more than 99% likelihood that the prevalence of the disease is between 3 and 7%. So that's one example where area under the curve is used in probability. All right. In physics, and again, if you think probability is just, I just mentioned the disease, but pretty much probability is at the heart of, at least the heart of modern conception of reality itself. So you can read Quantum Physics, the book I recommended, and see for yourself how probability is used and what do you need integration for. So physics, in physics you have additionally, even in classical physics, you have fundamental statements about physical quantities such as work, momentum, force, energy. All those things have to do with integrals. Okay, the statement that energy is preserved is a statement about integrals, can be viewed as a statement about integrals. At least when you have few forces involved. And the conservation of momentum is an integral property. It's the fundamental theorem of calculus, which is expressed in terms of area under the curve. Okay, so I hope, I'm not sure if I convince you at all at this point, but I'm hoping you understand that very interesting ideas usually are associated with something that's why nobody noticed it, right? With something that is not so right away seems related to it. So here is the idea, guys. So what do you do in calculus? In calculus, you are trying to describe a complicated phenomena using simple language, using the simple instance of that phenomena. In other words, when I try to describe curves, I use line segments. I describe a curve as an infinite chain of microscopic line segments. Now, if I want to find area, what's the simplest instance of objects for which area is obvious would I use? Understand? For curves, the simplest objects I use are lines. What would be the pixels for calculating area, the simple objects to find area? Write in the comments, please. That's very good. Ibad, what about the rest of you? I need to identify my pixels. What should they be? Yeah, thin, that's another story. That's later, but rectangle. Squares, we can use squares to build rectangles. So yes, so simplest areas are rectangles. Now, why is a rectangle so simple? Because you can imagine a rectangle that is, let's say, 4 by 2 is built out of many squares. And in other words, the 2 is like 2 unit squares across and 4 unit squares high. And then the area is just you count how many unit squares you have. It's 4 times 2, right? So in general, area is height times width because that's how many unit squares will fit in it. Okay? So given a curve f of x, we will be stalking myriad of tiny rectangles because their areas are simple to calculate. They are very tiny, and the width of one of them is going to be dx. Dx, little dx means very small dx, right? Are you with me so far, guys? So if I stack very many thin rectangles under the curve and I add their combined area, I will have a very good approximation to the area of the curve. So I can imagine this curve as this full curve as just a bunch of stocked on top of each other rectangles. Yes? And that is the reason for the notation. Are you with me? Look at it, guys. Here is the notation. This S stands from sum. This means what's the area of a typical rectangle? It's at this particular x, the rectangle will have height f of x and width dx. So f of x dx represents the area of an individual rectangle. And this elongated S is for sum. It means sum all the rectangles that you stacked from A to B. Yes? Stack the rectangles from A to B. Are you with me? Do you see how this notation is telling you the idea, what you're going to do? It's simple, I hope, right, guys? Do you understand the notation? I see only like what, at most 7 people participating. So everybody understood? Let's just check basic consciousness. Do you understand what is the simplest, the pixel, what I call it, or the simplest block to study area? Write the name of that simplest block in the comments, please, if you are here. I want to study area. There are complicated curves and there are less complicated objects. So what is the least complicated object for which I can calculate area? Write in the comments. A square, or more generally, a what? So I see what 5 people wrote something. It's a simple question, guys. Are you conscious? What's the simplest object for which I can easily calculate area? Okay. Okay, good. No, I didn't say square is easy, but rectangle is it just gives me more versatility. So you're right. Maybe the simplest is a square, but ping, that's funny. So trapezoids can also be used, but the simplest is in essence a rectangle. It's square, and then you can easily generalize it to a rectangle. It's convenient. Rectangles for this purpose are more convenient than just squares, because a rectangle is a generalized square. It gives you more flexibility, right? Every square is a rectangle, but not every rectangle is a square. Good? So then what we will do is underneath the curve, we will stack those individual rectangles. They will be very thin. Their altitude, you see we're stacking them under the curve. The altitude at point X will be f of x. And because they're thin, their width is dx. So what the idea will be this, to stack underneath the curve many very thin rectangles with altitude f of x and width dx, and then add them up together, add their areas together, and then you will have the area of the curve, the area under the curve. Because and so the notation tells you to do what? To stack rectangles from the point A to B, then sum the areas of those rectangles. So this is sum of the rectangles from A to B, and this is the area of those rectangles. Is it clear? Okay, now let's go to 3. Here is that idea again. Look at it. Do you see? Here is the curve, and here I placed many rectangles that are fairly thin. And the typical rectangle at position x has altitude f of x and width dx. Okay, and so this integral is to say some areas of all thin rectangular columns from x equal to a to x equal to b. So we have to be methodical to carry out this process. Okay, so let's try to understand how this process is carried out. Okay, so first of all, we might want to use the right-hand rule. And then basically, how do we decide where to erect this rectangle? We can partition the interval a to b. We can imagine building a bunch of rectangles. Each of their widths we may set to be the same. We may set them to be equal. Okay, so here I divided the interval and made them equal, and I said right n. R sub n means that at each right edge of the base, that's the point I will use to erect the altitude. Are you with me? You understand what I'm trying to do? I have some curve, and for that curve, I will want to build a bunch of rectangles. And I will use the right hand point to plug and create the altitude for the rectangle. Do you understand? This is my building plan. Clear? So I divided the interval from a to b by n segments, and then the width is going to be what? What's the width of one such segment? It's going to be b minus a divided by n. Clear? B minus a divided by n. And so let's try to describe the positions of x1, x2, x3 of the points at which I plan to erect the altitude. So I imagine asking for directions of the construction manager, and I start at the point A. So the first elevation will be constructed at the point x1, which is a plus 1 interval width. So 1 times the x. X2 will be constructed 2 blocks, right, from A. So it's a plus 2 times delta xn, which is a plus 2 times the length of the block. Do you understand? This is just like instructions on how do you move to the point at which you construct the altitude, and so on, right? In general, the cave rectangle will be constructed at the point xk, which is the right point. You understand? I decided to use the right hand method. In other words, I will divide the number line from a to b into n segments, and I will use the rightmost point of each segment to erect the altitude. Clear? It should be, guys. You see, I mean, I say things that are very obvious, I think, and then I have like a forever pause. I do not know if you understand it or what. We need to understand it fast. So in general, the cave point, the way to give directions to go to it, it's a plus k times b minus a divided by n. Okay, so Rn, in other words, means that we will create n thin skyscrapers. And the formula is this, right? The formula for the combined area of those skyscrapers is from k equal to 1, from first rectangle to the nth rectangle. And the area of the rectangle is the function evaluated at the right point xk multiplied by the width of the rectangle. Good? And so what is that? It's k equal 1 to n of f a plus k. Xk this is the directions to how to get to that point from a. Right? A plus k b minus a over n times b minus a over n. Clear? And so I can think of this integral as the limit as n goes to infinity of this right-hand method construction, which means construct n of them and then take the limit as n goes to infinity. So it will make the width shorter and it will make more rectangles. You understand? Let's try to see how that idea is supposed to be working for a particular example. Okay, we'll do this example, then I suppose we may part. Well, but we'll finish this example today. Good. So first of all, let's calculate the integral from 0 to 2 of x dx. So first of all, if you graph x dx, right? X is the skyline. If you graph the skyline, it's y equals x. It's just simply a line in this case. It looks like that. So without doing any integration, I pretty quickly can figure out what's the answer supposed to be, right? I'm just using this example to see if the answer I will obtain using this procedure will be the same for simple examples where this procedure is not needed. Yes, it's needed for complicated curves, but not for this particular one because it's very easy to find it. So from 0 to 2, it's a triangle that has width 2 and height. What's the height? What's the height, guys? Help me. Exactly. Y equals x. It is the same height. So the height is also 2. What's the area of this object? It's a triangle. You see it's a triangle. So the area A must equal to 1/2 times 2 times 2. Base times height, which is simply the area must be 2. You agree? If what I'm doing is correct, the area will happen to be 2. So let's see if I'm doing everything right. So here is going to be the procedure, okay? So the procedure is I'm going to create a numerous, and in general you have to think n because n will go to infinity, right? I'm going to create numerous skyscrapers. And so first I need to have their blocks, right? So I'm going to partition 0 to 2 into blocks. So what's the partition? It's going to be, if I want to create n rectangles, I have to take 2 divided by n. Good? 2 divided by n. So tell me, please, how do I get to the, how do I get to the kth rectangle? How do I get to the first rectangle? So I go from 0 and I add 1 times 2 over k. I'm getting on the first rectangle, I'm getting to the point, the right point of it, at which I will create the elevation. So in general, I need to think about the point xk. How do I get to the elevation to construct the kf altitude of the rectangle? So that means displace by k blocks, and the length of the block is delta xn, which is 2 over n. So the answer is 0 plus k times 2 over n. Are you with me, guys? Very important step. Confirm if you are with me. You understand that what is this point xk? I'm using this is my construction design. I'm going like this. So this is 0. This is first point. So I'm going to construct the rectangle here. Then I move to the second point and I construct the rectangle there and onwards, right? That's my construction plan. That's the rightmost point. So that I will use to construct the elevation on the first graph. This would be the second. This would be the third. You understand how I'm doing it? So do you get where the k times 2 over n comes from? Okay, that's the right point for the kf interval. Right point of kf interval. Again, that's what we had over there. I'm just gonna displace, right? So this is 0 to 2. Now, first interval, here is the first interval, I need to find what's x1. x1 is going to be displaced from 0 by 1 block. The sub n indicates that it's a block where I divided the full landscape into n blocks. And what's the length of that block? It's going to be 0 plus 2 divided by n. That's the length of one block. Yes. Now, if I want to get to the second point at which construction will take place, then x2 means start at 0 and displace 2 blocks. In other words, you displace by 2 multiplied by 2 over n. Don't multiply it out, just 2 times 2 over n. Yes. And in general, to get to the cave block, you need to displace by k times 2 over n. Yes. So then I have my points of interest. Then I need to figure out what is f of the general point k times 2 over n. Well, the function is not doing anything to the input. It's y equals x. So the altitude will be k times 2 over n, because the function is f of x equal to x. It's not changing the input. You see, the function is not doing anything to the input. So the altitude at the cave block will be k times 2 over n. And so now my formula becomes what? So the right hand sum, so where I add up the areas of those n rectangles, it's summation from 1 to n of fxk times delta xn. Now the altitude at the kf interval is k times 2 over n, and the width of it is 2 over n. Yes? So look what happens here. I am multiplying 2 over n times 2 over n, and I can factor it out. So it's 2 over n squared summation of k. Are you with me? It's 2 over n summation 1 all the way to n of the value k. 1, 2, 3, 4 all the way to n. And I can write this summation in simpler form. Because we remember we derived this formula. It would be 2 over n squared times n plus 1 divided by 2. Are you with me? And so the integral would be the limit as n goes to infinity, as I make the rectangles thinner and I make more of them. Now, what's the limit at infinity? It's very clear that all I have to do is take the leading coefficients. The leading coefficient here is 2 squared times n squared divided by 2 times n. So it would be 2 squared over 2, which is 2. So I got my answer just as I wish to get it. Good? Do you understand, guys, how I did it? Very simple idea, right? If you want, I can give you a problem to try on your own in office hours. Right, so I will. If not, I suppose you are dismissed. If you're interested, I can also show you very interesting questions from what, when, where that I did in the evening class. Right, to see how clever you are at solving interesting riddles. I can show you very interesting ones. So let me know what you'd like to do. If you want to go, you can go. If you want to see the riddle, I'll show you the riddle to rest a little bit and think of something else and then do the practice question. Or if you don't want to do any practice questions, then simply auf Wiedersehen. Or more so, I'm not even sure because we don't see each other. You see my face, I don't see your face or hear from you. All right. I am stopping the recording. No trouble, bud. So I'm stopping the recording and we'll see what you want to do.